Hello and welcome to today's video. We are going to look at colligative properties. When you look at the word colligative, we can say it comes from the word colligate. And to colligate, basically, it's like to group something, put something together, or to unite. Let us consider this to group. While properties, a property is like a characteristic, something that you can use to describe something else. So with colligative properties, our main focus is going to be on dilute solutions. Dilute solutions. That's my abbreviation for solutions. So when you're looking at these dilute solutions, all we need is a solvent and then a solute. Because water is so common and it's a universal solvent, we shall basically use water as our solvent. But all we have our water here, H2O, which is the solvent. And then we can get any other solid and try to add it into our water so that it dissolves. Let us say we have our salt. It could be sugar. It could be something else. So this is our solvent, solute. So once you dissolve some salt into our water, we shall get a dilute solution if at all the solvent is too large compared to our solute. So the way this solution that will be formed, we shall then have a solution, a salty solution. Maybe let us just say salt water solution. So the properties that this salt water solution will have will constitute what we shall call colligative properties. But these will mainly be depending on how much of the salt or the sugar we shall have added into our water. So what are some of these properties? That will depend on the number of particles of the salt or sugar that has been dissolved in our water, but not on their chemical nature. When you look at sugar and salt, totally these are different solids. One is ionic, the other is molecular. So you realize that they are totally different in terms of chemistry. However, when we are to look at colligative properties, these will be the properties of the solution that will depend on the number of solid particles, that is to say number of sugar particles or salt particles that have been dissolved in our water and not their chemical nature. So some of the colligative properties include, we have elevation in boiling point. Elevation in the boiling point. We all know that water has a boiling point of 100 degrees Celsius at standard atmospheric pressure. However, when we add some salt to this water and then try to boil it, we shall see that the temperature at which it will boil will be greater or higher than 100, maybe 103 degrees Celsius. So addition of salt or sugar into our water will elevate, that is to say will increase the boiling point of our water. So the elevation in boiling point or the increase in boiling point of our solution will be a property that is due to the number of salt or sugar particles that have dissolved in our water. So this is one of the properties. Whenever you have a solid dissolved in a solution or a solvent, we shall see an increase in boiling point. The second one is depression in freezing point. It's like freezing point lowering. So we shall still stick to our water. It freezes at 0 degrees Celsius, but when you have salty water, you realize that it will freeze at a temperature less than. This arrow will mean less than 0 degrees. This could be maybe negative 2 degrees Celsius. So the presence of the salt or the sugar in your water will cause the water to freeze or turn into a solid at a temperature less than the normal one, which is 0 degrees. So the depression in freezing point is like a property or a characteristic of this solvent of ours. But why is that so? Because there is a given number of particles. It could be salt particles or sugar particles that we have dissolved in our water. Then we also have osmosis. Now, osmosis, we shall always see a tendency of water entering into a given room or a given region in space as it passes through a certain semi-permeable membrane in which we have a solution enclosed. So if we have our solution here, maybe our salt water solution, and then we shall see a tendency of water molecules moving into the solution. However, we shall not see the solid particles in the solution trying to escape. So this osmosis is also due to the number of solid particles that have been dissolved in the water. So the more concentrated our solution will be, the more water will tend to enter into this solution as it crosses a semi-permeable membrane. And then lastly, and most important, is vapor pressure lowering, or we can say lowering of vapor pressure. So actually all these first three, 1, 2, 3, all occur or take place mainly because of this fourth, the lowering of vapor pressure. We know that for water to boil, the vapor pressure due to the water molecules must be equal to the atmospheric pressure. So when we add some salt into our water to create our solution, there is a way the salt particles or sugar particles will prevent the escaping tendency of the solution formed, basically of the water present. But in this case, the escaping tendency of our solution will be less, and as such, we shall have less vapor moving into the atmosphere because of the presence of some salt particles at the surface. Let's take an example of our container. Initially we had water, and then when we added some salt, sodium chloride ions, some of them will tend to align themselves to the surface. Remember, evaporation takes place at the surface. So escaping tendency of our water molecules will be limited due to the presence of these solid particles. So we shall have less vapor pressure. Less vapor pressure. So that means the vapor pressure of the solution will be less than the vapor pressure of the pure solvent. And as such, we shall see lowering of vapor pressure. And because of all this, we shall have elevation in boiling point, depression in freezing point. We shall also look at it in terms of osmosis. So lowering of vapor pressure is the fourth colligative property. We can describe a solution by looking at how the vapor pressure has been lowered and come to a conclusion on maybe the number of particles of the solute that have been dissolved in our solvent. That's all for today. This is just a brief introduction to colligative properties. In our next video, we are going to look at one of them. Probably we shall start with lowering of vapor pressure, and then we go to elevation in boiling point. Thanks for watching. Stay safe.